Today we're going to talk about adding and subtracting rational expressions, and if I notice that the video is getting too long, I may chop it into two parts. So the first problems we have, the first problem here, already has a common denominator, which is what we're looking for when we're adding and subtracting fractions. So if it already has a common denominator, then we just add our numerators, or in this case, subtract our numerators. So my common denominator, t minus 3, and my numerator, t squared minus 3t. And those aren't like terms, so there's nothing I can do with them, except now I'm looking at a rational expression, and perhaps I can put it in lowest terms. So let's think about that. If I factored a t out of the numerator, right, t times t minus 3, over my denominator, t minus 3, then I would have identical binomials, and I could just say my final answer is t. Here's almost a fraction problem, right, except for the x. Think about that. If I don't have a common denominator, then I actually work toward a common denominator, and I'm going to suggest maybe writing the problems with enough space so that you can get a common denominator. So between 4 and 14, let's hope we can agree that the common denominator would be 28. So I'd have to multiply this fraction, top and bottom, by 7, and this fraction, top and bottom, by 2. Then I would get 7x over 28 plus 10 over 28. So my common denominator, 28, and my numerator, 7x plus 10. There's nothing I can factor out of my numerator. They are already sort of prime, so that answer is done. Again, we do not have a common denominator, and hopefully what you're seeing here is that this denominator is a binomial. This denominator is a monomial. And so I can't just subtract 2 from numerator and denominator. That doesn't work. These denominators don't have anything in common. So I'm going to have to multiply this fraction by x over x, and this fraction by x minus 2 over x minus 2. Then I'm going to get 3x over, and you can multiply it out or not. I usually don't. X minus 2 minus, now I'm going to actually change this. I'm going to make this plus, and so that I remember to run the negative with the 2. So negative 2x plus 4 over x minus 2. So now my denominator, my common denominator, x minus 2, and my numerator, oh, I have some like terms this time. For the first time ever, I have some like terms. 3x and negative 2x are just x, and then plus 4. And there's my answer. Here I have 3 denominators, and they look like they are all different. I have r minus 3, I have r squared minus 3r. However, this denominator is, if I factor it, r times r minus 3. So I have an r minus 3, I have an r, and I have an r times r minus 3. So I think the common denominator is r times r minus 3. So this fraction needs to be multiplied by r. Then it would be r times r minus 3. This fraction needs to be multiplied by r minus 3. And this fraction doesn't need to be multiplied by anything because it already has r times r minus 3. So we can see our common denominator. I think what I'm going to do is I'm just going to write CD for common denominator and make a gigantic fraction bar. So this numerator is 2r squared. This numerator is a FOIL problem, so plus 2r minus 6 plus r squared minus 3r. And this numerator, minus negative 6, would be plus 6. I'm looking for like terms. So I have 2r squared and r squared. That makes 3r squared. I have 2r minus 3r, so that makes minus r. And then I have subtract 6, add 6, that makes 0. Over my common denominator, which, let me remind you, r minus 3. I would circle that and say I'm done, except my numerator has a greatest common factor of r. So I have r times 3r minus 1 over r times r minus 3. So now my r's will cancel, and I just have 3r minus 1 over r minus 3. That is my answer. Here's a problem where it looks like my denominator is not the same, but again, you may recall that 3 minus x is actually negative x plus 3, and if I factor out a negative 1, so really this problem is 8 over negative 1 x minus 3 minus 2 over x minus 3. So the only difference between these two is that the common denominator is going to be negative 1, x minus 3. So if I multiply this by negative 1, there, then I'll have it. So my common denominator and my numerator is 8 minus negative 2. So 8 plus 2. So I have 10 over negative 1 times x minus 3, which most times they're going to write this one of two ways. They're either going to multiply the negative, move the negative 1 so that it's like negative 10 over x minus 3, or they're going to multiply it back in here and say it's 10 over 3 minus x. Either one of these answers would be correct. This is also correct. It's just not usually done. Okay,